Okay, perfect. So welcome everyone. My name is Barnstedt. I'm the Chief Architect for Standards and Consortia at Microsoft in the Azure IoT team. And today I want to talk a little bit about, some of the articles online that you may have read about OPC UA versus MQTT, which is best, OPC UA versus the asset admin shell, which is best, and then figuring out how we can untangle this mess. So first of all, let me start by saying there is no OPC UA versus MQTT. So what happened is a bunch of companies that weren't aware of OPC UA pops up and that OPC UA pops up leverages MQTT, came up with alternative technology and then felt compelled to write articles comparing OPC UA and MQTT and didn't realize that there's actually a mapping defined in OPC UA actually leverages MQTT. So any articles that you find in relation to that, you can just ignore. And then there was a technology built by a number of companies in the US called Sparkplug B. And we need to talk about Sparkplug B a little bit because, again, there's a lot of alternative facts, let's call them, online that we need to clarify. And I'll attempt to do that with this slide. So first of all, a lot of times you read that the Sparkplug B standard, it's not a standard, right? It's a proprietary extension to MQTT. That doesn't make it a standard. MQTT is the standard. If you create an extension to it, you don't automatically become a standard. You have to go through the normal standardization process, just like OPC UA did many years ago. The other issue really with protobuf is that it uses, with Sparkplug, is that it uses protobuf payload invented by Google. And surprise, surprise, that's not supported in either AWS or Azure, which means that you need to translate the data in the cloud. Now, you might think, what's the big deal? Well, once you start using the cloud at scale, it becomes a really big deal because you have to pay for that data conversion. That data conversion becomes a real, compute overhead when you're using the cloud, with many, many different assets connected to it. And it adds no value. So you're much better off using a payload like JSON, for example, that all cloud services natively support. So you don't have to convert the data again in the cloud. And then another thing is, converting the data on the shop floor is also required because obviously a lot of times, data comes from all sorts of different machines. So you're converting it to OPC UA, or in the case of Sparkplug B, you may be converting it from OPC UA. Well, that conversion is not defined, right? So there's no mapping from OPC UA to Sparkplug, which means that any implementation will be different and usually, again, well, not usually, always proprietary. It's going to lock you into that particular data format and completely undermines the whole idea of multi-vendor interoperability, which is the goal of the OPC Foundation. So OPC UA has a mapping to OPC UA pops up, of course, and it's automatic. You don't need to do anything for it. So another thing is these articles that you read, if you read closely, you'll see that they've actually compared OPC UA client server technology to Sparkplug. Instead of comparing Sparkplug to OPC UA pops up, which is really the competing technology. And I mean, really that's an apples to oranges comparison. I wouldn't use OPC UA client server to send data to the cloud either, right? That's why we invented pops up, right? So really, a true comparison would be comparing OPC UA pops up to Sparkplug B, but I haven't come across these yet. Another thing is actually, the fact that Sparkplug B is an extension to MQTT, so it only works with MQTT, versus OPC UA is actually transport protocol independent, which means that, should a customer not support MQTT for some reason, then you can still use OPC UA and its standard mapping and its standardized payload format, even if MQTT is not available. I mean, I have customers asking me for Kafka support, instead of MQTT, and that just works if, you use the OPC UA payload with a Kafka broker, right? Now, obviously, Kafka is not part of the spec yet. We're considering it, depending on how things are going with some of the other consortia that we're working with. But in general, that's an easy addition to the OPC UA spec because it is a transport protocol independent. The good news about Sparkplug, it's not all bad. The good news is that it has a defined topic mapping, right? So, using the topic tree, you can actually discover your MQTT assets, right? And that's a good thing, right? So, as you probably heard Randy talk about, 2 days ago, there's now a proposed OPC UA PubSub topic mapping for MQTT. Some folks prefer to create their own mapping, which is also totally fine. So we're probably just going to make it a recommendation rather than, a strict mapping that must be adhered to. But in general, it's a good idea to define a topic mapping, and that's clearly what was missing from PubSub, which we corrected now. And then lastly, if you're committing to Sparkplug, you're really committing to a handful of companies that have implemented it. And that's totally fine if you want to do business with those companies, but should they decide to change the Sparkplug protocol at any time, they can do that because there's no standardization process behind it. So you might be stuck with an implementation that is out of date. So let's talk about OPC UA over MQTT, which is what everybody should be talking about. So again, don't confuse it with client server. It's a totally different technology with different communication patterns. Client server is request response. MQTT uses a broker and a bunch of publishers publishing to the broker and a bunch of subscribers reading from the broker. So that is actually a fantastic technology for cloud communication, and that's why it's used there. It's been around for a long time, right? So part 14 of the spec was released in 2017. It became an IEC standard 2018. Unfortunately, not a lot of people heard about it until more recently, when the large cloud vendors all committed to supporting it. And that's why there's so much confusion in the market. But anyway, we're trying to clear that up and give you the right facts that you can make your own decisions. Microsoft has been using it from the start. I mean, obviously, we worked on the spec in the OPC Foundation. We were the first to implement it. We were the first to have a product, the OPC Publisher, that supported it. And we're continuously improving that product, of course. And it's supported by thousands of companies, right? So since OPC UA is so prevalent in the industry, standardized mappings exist. So it is super easy to support PubSub or OPC UA over MQTT. And then you have all that interoperability at your fingertips. So what does it look like? Well, here's a sample of a message, a JSON message. There's also binary encoding, but obviously you can't read it, so I've picked the JSON encoding. And again, I actually prefer the JSON encoding because, obviously all the cloud services support JSON, and you can just ingest it without having to convert it again. So here's the JSON format, and as you can see, the white pieces are mandatory, the blue pieces are optional. So you can actually compress that message payload down significantly, because some people say, oh, JSON is chatty and too much overhead and all this. Well, you can reduce it down to the bare minimum, and then you get good performance. So we had, people always say, oh, what about the performance? Well, we have run tests with OPC Publisher, publishing 20,000 tags, OPC UA nodes, let's say, per second. on a single instance. So to the cloud, mind you. So it's very efficient. And I yet have to see a customer who wants to publish 20,000 tags per second, you know. So anyway, so here's the payload. So the important things are the message ID, the message type, because there's different message types. There's also UA metadata message, which is sent before the actual data payload from the publisher. It defines basically what the data set that you see here in this message contains, right? And it defines their names, display names, values, or not values, sorry, the types. The values then come in the actual UA data message. So some of the best practices for sending that data is the in the payload here in the middle, if you have the actual expanded node ID in there, it makes lookup of the metadata much simpler, right? So that would definitely be a recommendation. You can put in there whatever you want. You can put in the display name, for example. Some people choose that, but I think it should be the expanded node ID, and that will help you with the metadata lookup in the cloud. And another thing that you don't have to add, but it makes sense, of course, if you're building a time series, is to add a timestamp, right? So that's that would be a big improvement, obviously. Otherwise, you'll have to use the time when you ingest the message in the cloud, which, of course, there's usually a delay of up to a second, right? So you want to be a little bit more specific when trying to correlate different events that happen at the same time in your time series database. So timestamp, I would definitely recommend. And then there's two different types of encoding. There's the non-reversible encoding, which is basically just a value. And then there's the reversible encoding, which also includes the type. So in this example here, you see body is 99 and type is 6, which I think is an int. So you know how to parse the data in your time series database. But you don't have to send that information. That information is also in the metadata message. So much better would be to send the metadata message first, with all the type information, et cetera, and then just use the non-reversible encoding to save space in your cloud message. Okie dokie. So that myth, OPC UA versus MQTT, is hopefully busted. So let's talk about OPC UA versus the asset admin shell, right? So in general, we've seen through the Corona pandemic that resilient supply chains are a good idea, right? And, you know, also, you know, before Corona hit, the most important topic was climate change. You know, just because there was a pandemic doesn't mean that climate change is magically improved. We still need to fix the climate, which also means we need to calculate our carbon emissions when we're producing stuff, right? So the European Commission is actually going to put a carbon footprint mandate into a digital product passport that they're going to make law probably next year. So everybody who's producing anything and selling it in Europe will have to, you know, adopt this digital product passport, including carbon footprint data of that product. So how do you calculate the carbon footprint of a product which has a supply chain which is, you know, 10 vendors deep, right? You need a cross-platform communication mechanism for that. And, you know, this is all static data, right? This is not, you know, time series data. This is mainly static data that needs to be communicated. So the other problem is obviously not everybody's on Azure, although that would be great, right? So, you know, as you're moving from one supplier in the supply chain to the next, how do you exchange data if they're all on different cloud platforms, right? So that is where the asset admin shell comes in. So the asset admin shell was invented by the Platform Industry 4.0, and it's a vendor-neutral asset data sharing service. It's a shell, hence the name. So it contains data from different sources. Again, it's cross-platform. It covers the full life cycle of an asset, not just, the operational piece. So it also covers, the engineering of building the asset, manufacturing the asset, then its operation, obviously, and then finally its decommissioning. There are open source implementations of the asset admin shell on GitHub. I've contributed some of those. And, there's a REST interface for the asset admin shell, which is in final release candidate. It's nearing completion, available on Swagger Hub. So you can just click a button, it generates the code for you, and you can do your implementation. The actual file format for an asset admin shell is the OpenOffice XML format, which Microsoft invented, but it's a standard now. And there's a bunch of different reasons for using OpenOffice XML. It's simple. It's basically just a renamed zip file with an XML document describing the content. And again, you can put whatever you want into an asset admin shell, including but not limited to an OPC UA information model, for example, in NodeSet2 file format, right? You can put in PDFs, you can put in 3D Studio Max drawings of your asset, you can put in operational data, operational manuals, bitmaps, images of the asset in question. It's basically your machine readable product website. That's the way to think about the asset admin shell. So again, when you hear all these conversations, where should we use the asset admin shell? Where should we use OPC UA? There's all sorts of arguments back and forth. Well, if you remember what the Platform Industry 4.0 actually defined many years ago, every piece, everyone has their place in the reference architecture. So this is the so-called RAMI 4.0 cube, the reference architecture from the Platform Industry 4.0. And as you can see, each standard has their place. So for the engineering piece or the engineering phase of an asset, Automation ML is the recommended standard. For the operational piece, the maintenance, life cycle of an asset, it's OPC UA. And then basically when you're communicating data, so they have the ISO 95 pyramid on the Z-axis here. So it's kind of a three-dimensional architecture. You see in the connected world, right, beyond the enterprise, if you remember your ISO 95 pyramid, it's the very top. That's where the asset admin shell should be used. And that's the recommendation. But certainly not to, integrate an asset admin shell into a machine. That makes no sense. So, if I look at just the operational phase, because that's where OPC UA plays, the reference architecture becomes this. So as you can see, we have a manufacturer that has a factory, right? So this is called on-premises. So you have machines building a product. There's an MES that more than likely exists to control the machines that form a production line. And then when you're turning this into an industrial IoT solution, you probably have an edge gateway and a cloud gateway. The edge gateway sits on-prem, the cloud gateway sits in the manufacturer's enterprise cloud. Again, this is now the connected world in the RAMI 4.0 cube. There's a separate talk right after this actually about the UA Cloud Library, so I'm not going to talk too much about the UA Cloud Library. Just know that it's an online store of OPC UA information models. So if you are using machines on the shop floor that actually have an OPC UA interface, which hopefully they will, you can upload its OPC UA information model into the cloud library and then access it for looking up the metadata of the time series data that you're sending from the shop floor to the cloud into your time series database, which is here. directly from the cloud library. How that is done, on Azure, I can tell you how that is done in the next presentation. You probably have some sort of graph database as well, which defines your plant. Sometimes that's an OPC UA graph. I have customers using OPC UA for that. Sometimes it's something else. If you don't know what to use, come talk to me. I have a few ideas what makes sense there. But in general, if you're doing OE calculation, you need to know which machine belongs to what production line. And then you obviously have some sort of ERP database with probably all the bill of material for the products that you're building, and you have a product database, which is something that you would probably tap into for your product website, right? So then you come into the asset admin shell domain, which basically creates a repository of asset admin shells. It's a server with a web interface. Like I said, there's a REST interface now defined for it. And it queries all those databases for the information. So for example, for operational data, it queries the time series database. For product information, it queries the product database, and so on. And then you're going to need an asset admin shell client, which is probably something your customer down your supply chain. So if you're part of a supply chain, your customer will need an asset admin shell client to access the asset admin shell repository, download the asset admin shells included in it, so it knows all the data that it needs or the customer needs for example, calculating carbon emissions. And then most likely that customer will put the information into their ERP system. So basically the arrow that you see here, right, where you're loading data from the asset admin shell into the ERP system, is the same arrow you see up here, just one level down in the supply chain. And this is not just theory, this actually works. So we built a carbon reporting demonstrator in the Platform Industry 4.0 together with the Labs Network Industry 4.0, the OPC Foundation, and the Clean Energy and Smart Manufacturing Innovation Institute in the US. We wrote papers about it. We're going to show it at SPS. Obviously, SPS last year didn't happen, but we're going to show it at IoT Solution World Congress in 2 weeks in Barcelona, and then of course at Hannover Messe, both at the Platform Industry 4.0 booth and the OPC Foundation booth. So it's basically the same architecture, slightly simplified, less pieces in it. But in the case of the carbon reporting demonstrator, we had a Festo machine. That Festo machine was connected to a Festo gateway, sending OPC UA pub sub data via MQTT to a cloud gateway, in this case, Azure IoT Hub. Then we connected the Smart Innovation Platform from Sesame to it. They have their own dashboards for it. Azure Data Explorer is a time series database in this case. The UA Cloud Library was obviously integrated, and we uploaded the machine information model to the cloud library. It's a Festo didactic machine. And then the asset admin shell server queried the time series database and the UA Cloud Library for data from that particular asset, calculated its carbon report for producing, I think it was producing a plastic part, some description. So basically calculating the carbon report for producing that plastic part and making it available in an asset admin shell, which then could be downloaded using the asset admin shell package explorer, which is available online. It's free of charge, it's open source, it's an AAS client, right? So what did that look like overall? Well, here's a screenshot. So this is actually data directly from this particular demonstrator. So here's the Festo didactic machine, and here's the asset admin shell that comes with it, right? So just for completeness, I also integrated an automation ML model. So this is just an example model, but you can put in your own model. And the automation ML model is actually a sub-model within the asset admin shell. It's a file, and that file is directly included in the asset admin shell. And I took the effort of actually integrating an automation ML engine into the asset admin shell server, so you could directly parse the AML file and read the automation ML information model. And then, of course, like I mentioned, there's a submodel OPCUA, which is also a file, but in this case, it's not included directly in the asset admin shell, but read from the cloud library. And again, an OPCUA client and server was integrated, so you could parse the file. This is a nodeset file, as you can see, and directly browse the OPCUA information model within the asset admin shell. So this is how an integration should work and could work. And then, of course, you have all the other pieces that, you know, the Industrial Digital Twin Association talks about at length. I mean, for example, they have a standardized template for a nameplate or an identification. They're working on an OPCUA metadata template as well, where you get metadata about an OPCUA server, like its endpoints and what OPCUA profiles it supports, etc., etc. So that's coming, and then this can be integrated here as well. And down here on the energy model harmonized, we actually have the carbon report included, right? So again, it can be done, and this is how it should be done, in my opinion. So finally, I want to talk a little bit about some of the contributions I've recently made to the UA Cloud initiative. So you heard Stefan talking about UA Cloud really, you know, taking off right now with all the major cloud vendors committing to supporting it. So I thought we needed open source cross-platform reference implementations for all the different pieces that are part of the cloud initiative. You already heard a little bit about the UA Cloud library. You're going to hear a lot more in the next session about it. There is obviously more than just a cloud library. So we have also what I call a UA Cloud Publisher. It's basically an easy to use PubSub telemetry publisher application that runs on the edge, on-prem, has an easy to use user interface, you know, and supports obviously PubSub, including metadata, messages, etc., etc. So I use it a lot for testing purposes, but you know, it's quite complete, so you can use it as a reference. Another important piece is what I call the UA Cloud Commander. It's a online command and control app for OPCUA servers. So if you want to control your OPCUA server from the cloud or any location really, the UA Cloud Commander is an important piece, and it can be completely controlled via MQTT. So you don't need anything else, just an MQTT broker somewhere in the cloud, and it can then, so UA Cloud Commander also runs on the edge, and it talks to the MQTT broker, obviously subscribes to predefined topics that you then send messages to execute commands like, you know, read a node, read an OPCUA node, or write an OPCUA node, or call a method node on an OPCUA server. And then finally, there's a UA Cloud dashboard, which we've used extensively actually for OPCUA PubSub cloud testing purposes. So it's online. Again, it reads messages in both JSON and binary format. It parses metadata messages, so you can use it to test your PubSub implementation against. And a lot of people do that already. So all of those are available in my personal GitHub repo. There's pre-built Docker containers, so you don't even need to clone the repo or anything like that. You just run it. Just need a Docker environment to run it in, of course. And then the UA Cloud library is obviously on the official OPCUA OPC Foundation GitHub repo. So have a look at those. Maybe they're useful to you. I would hope so. And then let me know if you have any feedback or improvement suggestions. So with that, I'm at the end of my talk. So the only thing left to do is really to thank you for your listening, really, and I wish everybody peace, especially in Europe.